Hello, ladies and gentlemen. This is Leon Fulford here. Um, Pretty cool stuff I've got going on. Um, right here, we're gonna. I've been thinking about this project for quite some time, and I couldn't get my mind off of it. Uh, so as soon as I got some money to take on this project that I've been thinking about building for a while. What I want to build is an 8 outlet extension cord box. I talked to a lot of people about this for a while, and people were like, you're crazy. And why would you want to build something like that? And when you can already buy this stuff already made. And I'm just like, you know what? I'm going to build this because it's something I would like to do. I've been thinking about it. I love it. It's something of that, like a piece of art. It's kind of like I'm an artist in a way. But this right here is what you can get at Lowe's, and I was just at Lowe's earlier today. And this is the 8 outlet or receptacle box. This goes like right there, and as you can see, it's these were like 48 cents or something. Like, these were the cheap ones, real dirt cheap ones. And I've got enough of I bought what I needed, really. And what this is gonna do, and I wish I would have drawn this the schematic up for this, but what's more important than the schematic right now is I want to show you guys the NEC code. This is the 2011 edition. This is like the Bible of electricians. This right here will tell you what you can do, what you shall not do, according to this electrician's Bible. It's kind of like that, yeah. And you should. It's not permitted to. Say, for example, I'm going to read you. Okay. This says here, I'm going to read something pretty simple that I pulled to, is 300.4 of Article 300.4, wiring methods. Under 300.4 C1, it says here 600 volts, nominal or less. Conductors of AC and DC circuits rated 600 volts, nominal or less, shall be permitted to occupy the same equipment, wiring enclosure, cable, or raceway. All conductors shall have an insulation rating equal to at least the maximum circuit voltage applied to any conductor within the enclosure, cable, or raceway. That is according to Article 300.4 C1. And then it says here to see Article 725.136A for Class 2 and Class 3 circuit conductors. See, if you are not on board with this, this thing will read kind of like a Bible. If you do not have the mentality of what an electrician has, and you don't have the mentality to think outside the box, according to what a lot of these guys tell you, to think outside the box, you will not understand this book. I'm not trying to be, an idiot, or think or try to piss people off or be too arrogant about it, but this is the reality to it. Okay, what I want to build here inside this here is I'm going to have my conductors coming through here, these knockout holes, and then the schematic's gonna be, I'll draw it up here and I'll post another video, but according to table 310.15b16, according to this table, it says here that calculated based off the maximum amps that this will take before it burns this up, these connectors here, before it'll burn these up, you want to max it out on your calculations here. Now, don't ever max it out when you are hooking this up and like plug like a 15 amp vacuum or any kind of other 120 volt motor and plug like everything is maxed out at 15 amps. You will blow, and I'm telling you, you will probably blow not only just the breaker, and you'll burn a lot. You'll burn your wires up. Don't ever try that, because it'll blow quicker than anything. And it is there to, protect the circuit and basically keep your house from burning down. That's what that breaker is there for. And so what I said, well, is it according to this would mean that I would have to say, if I'm using the one particular kind of conductor, as far as wire gauge, this says basically that I would have to go ahead and use a number 1 AWG. A number 1 cable is going to be extremely big. In this case, we know logically that this thing is going to be plugged up to probably a 15 amp maximum outlet. The reason why I want to build this is to give you some options. Give you 8 different things to like I said, it's a piece of art, and I thought about it. Why not build it? It gives you 8 plug-ins. This doesn't mean that you're going to be able to operate 8 devices at once. This just gives you options. So if I got 50 foot, let's say I've got a 50-foot extension cord running from here all the way back to my receptacle at the plug-in, your receptacle in the wall, and this is on a construction site. Well, alright, well, I might have my Sawzall plugged up here. I might have my electric jigsaw plugged up here. I'll have maybe my shop vac. Another guy has shop vac plugged up here. Another guy has some plugged up down here. But they can't be running all at once. Now, if you go over your 15 amps, you go over your 15 amp limit on a 20 amp breaker, not only will it start cooking this one out, then it is also going to cook your breaker. And you don't want to go no more than 75% of 20 amps. So that's going to be probably right around 17.5, I would say, amps. Because once you exceed 75% of the maximum that the breaker can take, you are going to blow your breaker. It's going to heat up real quick, and before you know it, go boom, lights out. So this here is pretty interesting stuff. So now what I got to do with this is get to work. I'm going to make another video here real quick, because Facebook doesn't want you to go over probably like 10 minutes, I believe. So I'm going to draw my schematic, and we got some little things here that I bought from Lowe's, but I'll get into that in just a moment. But thanks a lot.